So, in this next exercise, we must graph the integration domain and then reverse the order. First, we should mark that x is outside, so x goes from 0 to 2, which will mean that on our coordinate system, x goes from 0 to 2, and our domain of integration will be in this strip. Now we can see that y goes from negative x to e to the x, so we must graph these functions too. This line is y equals negative x, and this curve is y equals e to the x, meeting the y-axis in the 1 point. And now we can see that our domain of integration is this region in green. Now, for reversing the order of integration, we should first write out what we want. We will need to integrate first by x, then by y. So now y is outside, so we need the minimum and maximum values of y. We can see here that y goes from negative 2 to e squared. And now all we need is the limits of x. For this we will need the inverse functions. For this line here, the inverse function will be x equals negative y, and for this curve here, the inverse function is x equals the natural logarithm of y. And now, here we can see that we have from the left side 3 different segments bounding our domain, and from the right side only a single segment, so we must divide our domain into these 3 parts. Now we will have 3 integrals, and the first one will be going from y equals negative 2 to y equals 0. And now we can see that if y is, for example, here, we have this line segment here, with x going from negative y to 2. And of course we have our function here, dx dy. For this next segment, we can see that we have y going from 0 to 1. And we can see that this is a rectangle, so x will simply go from 0 to 2. And for our last segment, we can see that y is going from 1 to e squared. And we can see that if we have a value of y here, we have this line segment with x going from the natural logarithm of y to 2. X equals the natural logarithm of y, x equals 2 fx y x